Hello everyone, good afternoon for everyone in Indonesia, and good morning Guten Morgen for all of the colleagues from the Netherlands. Welcome Han, Foko, and Peter Herman, and also the other participants that came from the Netherlands. So we will start the first session to be present. So the first session will be presented by Mr. Firman Hadi, and the title is The Dynamics of Shoreline Change of the Coastal Region of Sayung, the map using remote sensing and GIS techniques. For Firman Hadi, please, the time is yours.
Okay. Good afternoon, ladies and gentlemen. Okay. Good afternoon, everyone. It is an honor for me to present our result on this special occasion at this conference. So our title of the research is Shoreline Change Analysis of the Coastal Region of Sayung, the map using remote sensing and GIS technique. And the content of our presentation is introduction, method, and we will explain about current result, and we will reach the conclusion. So basically, the main reason why we chose this topic was because of the intensity of the damage of this area due to erosion. And previous researches concluded that the reason of this phenomenon or of this disaster were sea level rise and also land subsidence. And they applied different kind of methods such as PS INSAR, small baseline dataset INSAR, or using a digital shoreline analysis system, and also like Andreas et al. 2017, they applied the GPS measurement to understand the land subsidence in this region. But those researches, they use small numbers of observation, like Nandika et al. 2020, they use only 40 image pairs, and Muskananfola et al. 2020, they use 24 years of observation, consists of 5 satellite images, 5 epoch. So we would like to know what will be the effect of expanding the observation period and also increasing the number of observation to the result. And based on our motivation, our objective are to analyze the shoreline change in the period of before and after the development of Tanjung Emas Port. So basically, this is the different perspective. We wanted to know the difference of the shoreline change in before and after of the port development. And also we would like to analyze the relationship between the shoreline change and the rate of land subsidence in Semarang. And this is the area of our study. And basically, our method consists of two main pairs. First one is the image processing of Landsat using COSAT, and then we implemented NDWI for shoreline extraction. We will explain why we chose this one. And also after we got the data, then we utilize digital shoreline analysis system in ArcMap to understand the shoreline change, and we will have the erosion rate information. And for the second part, we implemented the time series in SAR using LIXAR, and instead of for example 40 INSAR pairs that like implemented by Nandika before, we use more than 100 INSAR pairs, and we will get the line of sight displacement rate. And this is the basic diagram of COSAT. So basically this software can extract the shoreline, but due to the type of the shoreline or the coastline in Sayung, which is not a sandy beach, we could not get a proper shoreline or coastline boundary by using this method. So that's why we use the software for this part until pre-processing. This is the reason. In 1994, we could get a proper boundary of the coastal area, but in 1995, so we have this boundary reach further to the land. So this is not the good result. So that's why we decided not to use COSAT. Instead, we chose to implement it normalized difference water index. And we use LIXAR. This is a service available in the internet that we can download pairs of coherence, geocoherence, and geocorrected unwrapped imagery that we can use for the insight. Our result explains that there was no significant difference between endpoint rates in 1980 and until 2000. So this is the period before the port development, and we have the net shoreline movement in the period before port development was minus 239. This is very much different with the net shoreline movement after the port development. So the result is different with Muskanan Fola et al., but their result seems to, I mean, the result tend to increase. Yeah. The net shoreline movement tend to increase to the recent period. If we compare our result, the right part is our result, and the next, the left side is Muskanan Fola's result. We can see the difference in detecting the area by the same software, but maybe it was due to the different in interpretation of what is the outer part of the coastline. So we observe this. This is the outer part of the coastline, but Muskanan Fola et al. Interpreted this part is the outer part of the coastline. So that's why the result was very much different. And also this is the screenshot of the process by using LIC-SBUS. We can see the software is downloading 973 image pairs, and this is the result of 1 year image pairs. And the next part is the result from 4 and 5 years. So by increasing the number of observation, we can increase the precision of the result. So by comparing the shoreline change and the land subsidence information, we can see that in this region there is an increasing rate of land subsidence. So we expect in the near future there will be more areas affected by the sea erosion and the sea level rise in this area. And we found that the villages affected by the erosion is increasing after 2000 and 2020. So the conclusion of our result of our research is that the open source software such as COSAT, Lixar, and LeakSBus can increase the precision of land subsidence measurement significantly with much less processing. And also our result support previous research on the effect of land subsidence to the shoreline change. And it seems that if we don't do any management or any activities to reduce the effect of the severe erosion, it will the area affected will be extended in the future. And we also have to analyze what kind of processing are needed to compare our results with previous researchers. So that's all of our presentation. Thank you very much for your kind attention.
Okay, thank you, Mr. Firman Hadi, for the great presentation from you. And it was an interesting study from you, and we will have a discussion after all of the presenters present their research. So the next presenter is Mrs. Elina. The time is yours, please, Mrs. Elina, to share your presentation. Thank you. Mrs. Elina? Yeah, okay, thank you. Please unmute yourself and start to communicate in this session. Miss Elina, you don't have your voice. I cannot hear your voice. Can you upper your voice because it's too low? Please raise your voice.
Halo, Assalamualaikum.
Yeah, okay.
Can you hear my voice?
But a little bit higher, your voice, make it higher, your voice. And please full screen your presentation.
Hello?
Yeah, okay, that's much better. Okay, you have just 10 minutes, so you have to start now.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. Thank you for coming to this presentation. Let me introduce myself. My name is Elina Putri Handayani. I'm a student of Oceanography, Universitas Diponegoro. In this opportunity, I would like to present about our research entitled Application of Permeable Breakwater Structure to Wave Damping as a Disaster Mitigation Effort in Sayung Waters, Demak. And this is my team, Professor Dr. Denny Nugroho Sugianto, STMSI, and Dr. PI Aris Ismanto, SSC, MSI. And first, I will explain to you about the problem behind this research. The MAC Central Java is an area with high erosion problems and shoreline degradation. Land conversion and ocean dynamics are the main factors that cause the erosion. The conversion land of mangrove in the coastal area, especially Timbul Loko village, as a sedimentation area, has been turned into aquaculture land since 1980. So this caused the loss of mangrove forests as coastal protection. Permeable breakwater is a solution that applies to solve this problem. It functions to dam wave energy to create calm water condition by adapting the mangrove root system to increase the amount of suspended sediment in the water ecosystem. And for this research, the permeable structure was built in July 2019 at a depth of 0.40 meters using bamboo as the main material because its economic value and easy to find. But bamboo is, according to Pojo, bamboo is an organic material that's susceptible to attack by pests and disease or boring organism. So here we calculate the effectiveness of wave damping from this structure and to analyze the strength of bamboo as the main material of the structure. For the first result is mini wave gauge data, and this is graph of wave height in measuring on Sayung Waters Demak. And this is graph of wave period. So based on this data, we find that the waters of Sayung Demak is a transitional wave or medium water waves based their relative depth, the value of 0.47, which is included in these categories. Next, the wave forecasting Sugianto et al. Based on this result, we find that Sayung Waters Demak has the characteristic of wave generated by the wind with wave period between 1 until 10 seconds. And according to Bayong, 2004, the wave season has higher wave height than other season because of the wind speed is bigger than other season. Next, to calculate the effectiveness of wave damping, we use ultrasonic sensors. Ultrasonic sensors are installed at the front and back of the permeable structure at the curtain height above sea level to determine the value of incident wave and transmitted wave. So this is the result, measurement on February 2020, March 2020, and April 2020. So in table 3 and 4, we find the value of effectiveness of wave damping and transmission coefficient. So transmission coefficient is useful in providing information on the value of energy transmitted from wave passing through a permeable structure. The greatest ability to damp the wave occurred in April, 37.35%, which is included in transition 1 season. This is because the value of incident wave in April is lower than the value of incident wave in other months. The next structure monitoring.
Elina, you have just 1 more minute.
The result.
Elina, you just have 1 more minute. Yeah.
This is the result of monitoring structure. This is the condition of bamboo. We slowly start to weak and break and block of material construction breakwater by boring organism. The last strength of bamboo measurement bamboo is sampled with UTM, Universal Testing Machine, and we find that the result of strength of bamboo sample for 4th month in the sea. This is the illustration of bamboo in the sea, and sample of Fourth sample has the greatest study price value among other bamboo sample placed in the sea, namely 5,477.52 Newton per square centimeter. This value explains that the fourth sample is still in good condition because the bamboo is protected by sediment, so that the effect of action of wave and current is very small and protect for the boring organism. In addition, according to Sugianto et al. 2020, bamboo with large amount of attacked boring organism will slowly weaken and break so that it will produce a small sturdy press value from the bamboo. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, thank you, Mrs. Elina. It was a good presentation, and we will please stop your share screen. Stop your share screen. Yeah, thank you. And we will continue with our next presenter. The next presenter is Intan Hapsari Surya Putri with the title of a preliminary study of land use land cover change and hydrometeorological disaster in north coast of Central Java. Okay, Mrs. Intan. Yeah, okay, please.
Good afternoon, ladies and gentlemen. My name is Intan. In this session, I would like to present this paper about a title of a preliminary study of impact on use and cover change and hydrometeorological disaster in Central Java. This presentation consists of 5 sections: background, study area, data and method, findings, and conclusion. For the introductions, I would like to start with the terms of urbanization in Central Java. As we know that urbanization is the main cause of change in hydrologic process, loss of existing drainage capacity, and flooding in urban areas. It is also known that the change in the land use pattern due to rapid urbanization negatively influenced the hydrological process in a catchment, leading to a degrading water environment. Besides, hydrometeorological disaster is one of common natural disasters in Indonesia. It includes floods, drought, and landslide. But for this occasion, because this is the preliminary study, I would like to start with the flood. And then last, as we know, as the most developed area in Central Java, urbanization has contributed to rapid urbanization in this area, which around 40% people live in north coastal area of Central Java. So based on the conditions, this research aims to prove that land use change does matter for hydrological disaster in the coast of Central Java in terms of upstream and downstream area by using the quantitative methods and GIS. For the objective, this paper tried to analyze the land use and land cover change in the coastal Java for 2009 to 2018, and the second to analyze the disaster event in the coast of Central Java in the same period of time. This is the study area of this research. It's located in the Central Java. We know that the total area is around 16,000 square kilometers, which cuts across 4 cities in the coast of Central Java, from the west is Tegal, Kalongan, Semarang, and Salatiga, and the other 17 regencies. For the data and methods, there are several data. We have a spatial data and a spatial data, which spatial data related to the land use, slope elevations, the delineations that we got from many resources. And while for the non-spatial data, it is related to rainfall intensity, disaster events, river debits for the whole research. And then for the findings, as we can see in the picture, there are two pictures consists of the conditions in 29 and 2018. In the left 29 and in the right is 2018. We can see that there is a huge increase of the built-up area, especially in Semarang, Tegal, Pekalongan, and also near the Kudus, Pati, and Rembang. We can see that there is a lot of increase of built-up area. And if we zoom in for every river basin, we can see that Semarang city has the most significant increase of land use. As we know that all river basins experience a higher growth rate of land conversion in upstream and explain about the land use condition in upstream, midstream, and downstream in the four river basin. As we can see that, urban center is most of the basin located in the downstream has been quite dense and compact for various built-up uses in the earlier period, and accordingly, urban expansion is extended to the direction of the upstream and midstream. And this is some of the land conversion from 29 to 2018 that Bodhikuto has a lot of change in the built-up area. It is indicate that in Bodhikuto, especially in the midstream, has a lot of development since the built-up area increased significantly from 30 to 52 square meter in 2018. But overall, as we can see that built-up area in all areas are increased. Related to the disaster events, the map of the area with picture about the conditions that we can see the frequency of flood in the four river basins are fluctuates from 2014 to 2018 generally. It was evident that flood dominantly occurs in the downstream area rather than in the upstream and midstream area, as we can see in the picture. The area which the red or dark brown indicates that there are a lot of or more flood events in that location. We can see that increasing urbanization promotes flooding with excess rainfall due to the increase of the total impervious area. As you can see that, Jordan Salona will has the most flood compared to the others. So, for the conclusion, we can see that first, we can conclude that the most significant exposure of flood is at the downstream area that is mostly defined as the urban center, for example, Semarang, Kalongan, Tegal. And second, industrialization from below is happening and potentially leading to an increasing disaster rate that is not necessarily located in the big urban center. This is proven by in the Kendal area. And one key issue that can be deduced from the result of the study is that there is a relationship of land use change and disaster events. However, this is not always straightforward. And the last, disaster risk reduction through proper land use planning and controlling is an essential instrument for safeguarding coastal areas. That's all that I can present. Thank you for your attention.
Okay, thank you very much for the nice presentation from Intan. So we will continue with the next presenter. So the next presenter will be presented by Miss Yunia. So this is the paper from Pak Helvinalis and Bu Yunia with the title is The Important Role of Gravel and Rocky Beach as a Natural Stable Form of Shore Defense in Southern Garut, West Java. So for Mrs. Yunia, you have 10 minutes to present your study. The time is yours.
Paris.
Yes.
I'm sorry because Neo is still login, but is have problem with the
PowerPoint.
PowerPoint.
Okay.
Can you
Okay, Pak Helvi, maybe we can skip this session and we can continue your session at the end of the presentation. Is that okay? So you will present at 14:40.
Yeah, continue this session.
Yeah, okay. Okay, I will continue with the next presenter. Thank you, Pak Helvi, for the information. Okay, let us do the video, please.
Paris.
Yeah. Yes.
When the time for us?
14:40. 14:40. At the end presentation.
There is no voice. I cannot hear you.
Oh, 14:40. I will check the time.
I cannot read.
Yeah. Okay. Maybe we
I cannot hear. Paris.
Yeah, you can read at the chat column, Mr. Helvi. It's you can present at 14:40, so the time will not be too long for us. Yeah.
from Japan, and I'm really enjoying this ICTCRED 2019. I enjoyed the whole stay in Semarang and Karimun Jawa Island. That was a real beautiful island. I really enjoyed this program. Thank you.
For ICTCRED 2019, we are so happy to be here, to be part of ICTCRED family, and I would like to say thank you to the organizer and then to all the committee. They are so superb, the food are so delicious, and then
thank you for the next level hospitality. As well, the divers who managed to train and accompany us during the snorkeling activity in Karimun Jawa.
I appreciate all the programs that you had done for us, and I hope that the program will benefit us in future.
And I can say, even though we just knew each other about 10 days, it feels like 10 months.
It's a great course because I can compare with maybe Sweden, maybe Indonesia, maybe Japan, maybe Malaysia, their culture and their language. We can find a lot of funny things between different culture. Yes, I suggest all the people will come here to join this club.
The ICTCRED trip has been really cool, really interesting. My favorite part was the trip to Karimun Jawa because we got to go snorkeling at coral reefs, and that was just an incredible experience seeing it up close. In Indonesia, it's been really interesting. People have been so hospitable, and then in this program, it's been very cool. It's just fun to hang out with people from different backgrounds. When you're all doing it together, it makes more connections, which is sweet.
It was nice bonding with other students from Malaysia, Taiwan, and Japan. We also had some lectures towards the beginning, which taught us about mangrove conservation and ocean conservation, and it really stressed the importance of trying to save our biodiversity. We also learned a lot about land subsidence and that problem in Semarang. And I think I really had a great time. The highlight of the trip was definitely the excursion to Karimun Jawa.
It was really fun to be able to be in the ocean in Indonesia with the crystal clear blue water and see the coral. Karimun Jawa was really fun, and it's been great being able to meet people from all different cultures. Coming from the United States was very different and very far from Indonesia, so to see the different cultures and just how certain things are done differently was really interesting for me. All of the people that we've had the chance to work with have been really nice and welcoming and helpful, and it's been really great being here.
This is my first time to Indonesia and Semarang and Karimun Jawa. I'm happy to join this program.
It's been great meeting new people and everyone, the new cultures, and being able to see the city and great hospitality from all the students and everyone at UNDIP. And during the ICTCRED program, I really enjoyed the snorkeling opportunities we had and just being able to spend time with everybody.
The
the ICTCRED event is absolutely marvelous.
This course, I think you should apply for it. It has been a great opportunity to meet lovely people.
Okay, sorry for the for the miscommunication. So we will start with Pak Wisnu to present. So Pak Wisnu, are you ready to share your screen? You have 10 minutes to present. Pak Wisnu, can you hear my voice? Yeah, Pak Wisnu, can you share your screen? Yeah, okay, thank you. Okay, Pak Wisnu, you have 10 minutes to present. So the time is yours, Pak Wisnu.
Yeah, thank you, Pak Aris. Okay, hi everybody. I would like to share, this is the finding of my research in Pekalongan city. It is about the vulnerability assessment of flood-affected areas in the North Pekalongan sub-district, but only based on socioeconomic characteristics. I am focusing on the socioeconomic characteristic because in the terms of physical conditions, I think is similar or somewhat similar of the vulnerable areas in the coastal region of the Pekalongan city. So I want to examine to what extent the socio-economic characteristics influence the level of vulnerability of the community. So I will start with the brief conditions of the flood-affected areas in the study area. As we know that the climate change brings hazards to some areas, especially in the coastal regions. Yeah. So from the study area, we know that there are seven villages, yeah, of the North Pekalongan sub-districts, yeah, that suffering from the tidal flood inundations, yeah, as well as the land subsidence. Yeah. There is statistical data that show that the average height of 50 centimeters flood reach until 4 kilometers area from the coastline, yeah, and the range from 4.8 to 10.8 centimeters per year of land subsidence also occurred in the study area. Yeah. So the intensity of the let's say the conditions or the poor conditions is highly influenced by the high intensity of urban activities, especially there are small and micro industries, yeah, batik industries, and as well as the densely populated area that make the living environment become poorer. Yeah. Statistical data also shows that the number of vulnerable neighborhoods is also continuously increased. Yeah. So as I mentioned before, the study aims to examine the effect of the socioeconomic characteristics on the vulnerability level of the community. This is the fact about the demography and educational level. Yeah, from the presentations or from the data, we can see that 7 vulnerable villages, yeah, is population density. I think they have high population density. Yeah, about 450 4,100 people per square kilometers, yeah, which is dominated by the female populations. And Kelurahan Krapia of Krapia village, yeah, is the highest populations, yeah, in number of populations, while the lowest one is the Kelurahan Bandengan, yeah, or Bandengan village in the study area. And yeah, the other data is about the poverty or level of income. Yeah, so we counted the number of subsistence households in 2018. Yeah, so based on statistical data in 2018, the sub-districts with the highest number of subsistence households was Krapia village, yeah, with around 500 families, and Kandang Panjang village with 470 families. Yeah, and we know that the livelihood or the occupancy, yeah, we can see that yeah, most of the people or most of the vulnerable community works in the informal economy, yeah, in the construction sector or in the trading sectors, yeah, as well as in industrial sectors. Yeah, so I think these groups, yeah, of the informal economy contribute the high proportions, yeah, of the occupancy or livelihood. And this is the scoring criteria, the variables. There are 6 variables, yeah, that has been examined, yeah, with the scoring criteria. We associated with the 3 scores, yeah, scores 1, scores 2, and scores 3. Yeah, this is yeah, the analysis on which the vulnerability level will be counted. Yeah, this is the spatial patterns. Yeah, in this study we map the patterns of the population density. Yeah, and the other patterns like the vulnerable people. Yeah, we focusing on the non-productive age. Yeah, especially the number of children and the number of elderly. Yeah, so in those 7 villages, yeah, 7 vulnerable villages, we can have a map like this. Yeah, so based on the analysis, it shows that the high population, yeah, for example, the spatial pattern of the population density, it shows that the high population density take place in 4 villages, yeah, in Kanjang Wetan, in Kandang Panjang, in Panjang Baru, and in Padukuhan Keraton. Yeah. So this area also shows the poor settlement conditions. Yeah. So I think this data confirms that the population density associated with the yeah, settlement conditions or the living environment conditions, as well as if we look at the data of the number of children and elderly people. Yeah, we can see that this age group also contribute to the vulnerability level of the community. Only 1 more minute, Pak Aris. Yeah, so let me turn to the final slides. Yeah, the last slides. Yeah. So based on the spatial patterns of each variables, yeah, we can conclude that the vulnerability of the people, yeah, the community in the North Pekalongan districts is confirmed that it is influenced, yeah, by the several factors of socio-economic characteristics. Yeah, as I mean before, as I mentioned before, that is the population density, income level, education level, gender, and the occupancy. There are the 6 factors that have been examined, and it confirmed that the number yeah, contribute to the level of the vulnerability. So we have classifications like this. Yeah, the lower vulnerability, the medium vulnerability, and the higher vulnerability. Yeah, so from the study, we can see or we can find that the vulnerability level, the Kerapia, Panjang Baru, and Kandang Panjang become the highest level in terms of the vulnerability, and while the Panjang Wetan village is the lowest one. So I think the study reflects how the socio-economic characteristics become the determinant factors or the determinant aspects to be considered, because the vulnerability is not only affected by the physical conditions or the topographical conditions, even by the land subsidence, but in this study it is realized that the socio-economic characteristics become the determinant factors. So I think we have to imply some policy with regard to the socio-economic improvement. So I think that is the results of the our research that I want to be shared. I think that is all, Pak Aris.
Okay.
Thank you very much for the attention.
Thank you, Pak Wisnu, for the great presentation. So we will continue with our next presenter, Mr. Peter Herman. So the title from Peter is Building with Nature in the Map on the Integration of Ecology and Physical Processes. So in this class, this is a special class for the project. So Peter will explain more about this project that has been held for the past 4 years, I think. 3 until 4 years that we already collaborate between UNDIP and also the Netherlands. Okay, please, Peter, the time is yours.
Thank you very much, Aris, and also thank you for allowing us to present this research on this conference. We feel honored to be your guests. I will present the results of the Biomanco project, which is a joint project of Technical University of Delft, Netherlands Institute of Sea Research, and UNDIP. And we're very grateful that we had so much cooperation and so much support from UNDIP to perform this research, and we're proud to present the first results. When we started this project, we had this very general conceptual idea that along coastal area, this is a transect through the coast where there is a mangrove forest. The mangroves are play an important role in stabilizing the coast. You have physical processes like the tide and the waves that stir up and transport sediment, but that can also be responsible for erosion, and the mangrove forest will have an effect on the waves by damping it. It will have an effect on the sediment by fixing it. And together, this may lead to a net sedimentation and a stabilization of the coastal position. But you have to realize, first of all, that the net sedimentation is usually very small compared to the gross fluxes. You have a lot of sediment transported towards the coast, have a lot of sediment transported from the coast back into the sea, and there's only a small net difference between them that makes up whether your coast will be net sedimenting or net eroding. And the other thing is that the role of the waves is very double in this. On the one hand, you hate them because they erode your coast, but you also need them because they are the main factor that stirs up and transports sediment towards the coast. So there is no point in keeping all the waves out if you want to stabilize your coast, but you have to be creative somehow in managing wave impact on the coast. And this delicate balance is easily distorted. For instance, if you make hard barriers and you reclaim land and you move your hard barriers towards the sea, your coast will become more reflective. and the waves that you needed to transport your sediment now become mostly an erosive force, and they will tend to destabilize your coastal profile, and the morphology will adapt. There will be sediment lost, and your coast can actually retreat as soon as your hard defenses will be destabilized. So you shift your balance between gross influx and gross outflux towards net erosion, and an erosive coast is very difficult to maintain. Now, our idea was that by putting these permeable dams, we could keep the stirring and transporting effect of the waves, so we keep the waves mobilizing sediment and bringing it towards the coast, but we could dampen them with the permeable dams so that we reduce their erosive force, that we allow for net sedimentation and new opportunities for mangroves to grow along the coast, and then take over the function of these permeable dams in the longer future. And one of the requirements for that may be that you have to move back your hard defenses so as to provide enough space for this mangrove greenbelt to develop. Now, this was the idea we had before starting our study, but as is usually the case, reality turned out to be a little bit more complex. One of the most important complicating factors is the importance of subsidence in this region. We had not estimated the rate of subsidence right when we started this, and we were we see every day the effects of that on the total coastal system. The other things we saw was the complex interactions of waves, sediment dynamics, and morphology that turned out to be difficult to completely understand. And the same was true for the complex interaction between ecology and physics, if you look at exactly what the mangrove trees can support and what they can't. As I said, subsidence is really an important factor. If your entire coastal profile is sinking, of course you create the need for a lot of sediment just to maintain your coastline in place. Now, there are several studies, there are several high-quality studies of subsidence in Semarang. We have very detailed image of the subsidence rates there, but the studies of subsidence in the MAC are more recent, and they are still coming up. So the results are a little bit less sure on the correct magnitude of the subsidence in this area. But what we do know from publications, for instance, this one of UONO, but there are many more, is that the subsidence is somewhere in the order of 5 to 12 centimeters per year. Now, we know historically that there has been a seaward propagation of this coastline at a speed of approximately, on average, over the past centuries, 8 meters per year. And with a 1 in 1,000 coastal profile, this means that on average, we've had something like 8 millimeters per year vertical accretion. And this vertical accretion in the order of 1 centimeter is almost an order of magnitude lower than the actual rates of subsidence we have now. And that means that there is a deficit in the sediment balance of the coastal region in total by approximately an order of magnitude. And there is nothing you can do about that. Your coast cannot be maintained if it loses sediment by subsidence at this rate. Now, another thing we saw is that the coastal processes are quite complex. And one feature we saw appearing, and you will hear more about that in the talk by Silke Tas, are the so-called chaniers, which are sand lances that appear probably as a result of redistribution of sediment after coastal erosion and sediment sorting, so that the sand is actually brought together into these chaniers. And these chaniers have a very complex interaction with waves, because the waves form them, the waves move them, and the waves destroy them. And just how that happens and in which seasons that happens has a lot of implications also for what happens at the leeward side of these channels, because the channels are a protective force, waves break on them, and often we see that there is an opportunity for mangroves to develop at the leeward side of the channels. And understanding these complex dynamics is really important if you want to understand how sediment moves in the coastal system. We also saw that the construction of the permeable dams was more complex than originally thought. Alejandra will talk you into the details of constructing the dams. There are two very important aspects on dam construction. First is how would you make them to maximize wave damping and minimize wave reflection? But the other is, where would you place them? How close to the coast must they be? Because however you construct them, there will always be a limitation to the transport through these permeable dams. You can make openings to increase transport, but even then, it will be less than without a dam. And considering that you have to fill up this entire area with new sediment, there must of course be a balance between how much transport you block and how much sediment you allow into the bay with respect to what you can expect in terms of sedimentation. So the proper design of the dams and the proper design of the placement of the dams is very important for success or failure of these coastal restoration measures. And also very important is, what can the mangroves do? What can the mangroves support? Especially the stability of the seaward boundary is very precarious. And it could be that this is inherently unstable, that mangroves can either be expanding or retreating, but never be stable in place. And it is complicated by the fact that the mangroves may probably also have an influence on this formation of channels, because they are a sink for fine sediment, and they can probably influence the sediment sorting processes. Besides that, the mangroves are under severe stress from the subsidence, because they're actually drowning. And what we see is that their resilience is large when they are large trees, but the small trees may actually fail in the recruitment because the height of sediment where they start growing lowers, and then the stress increases too much. But Celine will talk you into the details of this. And also there is human stress, for instance, in the form of plastics. Now, what can we conclude from this study? As I said, reality is more complex than simple schemes, and we know that is almost always the case. We've seen that morphodynamics is closely linked to wave action, and that understanding this complex interaction of what waves do in the coastal system is really important to understand where and how these solutions for coastal restoration may work. We've seen that the permeable dams can be optimized, not only with respect to construction, but also with respect to placement. We've seen that the mangrove dynamics at the seaward edge are crucially dependent on the waves, on the morphodynamics, and on the effects of the dams. And all of this has to be compared to their natural tolerance. The sediment balance is really important in these type of endeavors. And the subsidence is the major boundary condition that needs more study and more control in this system. And overall, we've seen that only a multidisciplinary approach can advance our understanding enough. So we hope that in the future, there will be a development of knowledge on, and most especially control of the subsidence. It is really a top priority for this region. Even then, only patches of coastal area may be safe from drowning. It will not be possible to save the entire coast. And we will have to better understand the natural dynamics plus the rules for dam design to improve our success in conserving these particular areas. Thank you.
Okay, thank you very much, Peter. It was a very interesting presentation from you, and we still have a lot of homework then. Okay. Okay, maybe for the next presenter, it will be presented by Alejandra Gijón with the title Mangrove Habitat Restoration Using Bamboo Structures. Miss Alejandra?
Hi, Aris.
Hi.
I'll show my screen.
Okay, thank you. Okay, you have 10 minutes to present.
Yeah.
Thank you. The time is yours.
Thanks. So, hi everybody. I'm Alejandra. I'm one of the 3 PhD students of the Biomanco project that Peter just introduced. And basically, we aim to restore mangroves in the MAC. And in general, of course, the insights of our research can also apply to other eroding coastlines. So this is the example of the coastline of the MAC. And here you can see a picture of 1982, where I have shown the coastline position with the line. And then you can see that over time, the coastline is retreating with maximum retreat rates of 5 kilometers at some locations. And why is this happening? Well, it's a number of reasons together, but one of them is that this area before was covered by mangroves, which were attenuating the waves. And when the mangroves were removed, of course, this means that higher waves can reach the coastline, which increases the stirring up of sediment by waves, and then this sediment can be transported offshore. The result of this, in combination with the local subsidence, is a decrease of the bed level. And in order to mitigate this decrease in the bed level, permeable structures have been built to mitigate erosion, consisting of bamboo poles and also different configurations that I will discuss later. The idea is that these structures, they mitigate waves, which reduces the wave height behind the structures and favors sediment deposition. This allows the bed level to build up, creating new habitat for the mangroves and favoring mangrove establishment. As I said, different designs have been tried in the field, some of them consisting of vertical bamboo poles, like this. Others also have horizontal bamboo poles. And one of the most common designs, as you saw in a previous presentation, consists of bamboo poles with a bag containing branches. This is what we call brushwood and the brushwood structures. But then we don't really know which of these different designs may be more efficient and particularly would allow to save costs for materials. So basically we said a number of possibilities. We said, okay, we have a number of bamboo poles and we can place them in different ways. Which placement is more cost efficient? So going from left to right, you can have the poles sparsely placed and then have less elements, so far from each other. You could have the elements closer to each other, like in the center picture, or you could decide to place them in rows. So basically you put the elements with a small spacing in the direction perpendicular to the waves, but with a bigger separation in the wave direction. And in order to test this, what we did is flume experiments, and I show this here. So in the lower left picture, you can see a wave flume, which is basically a tank with water when you can make waves, and then you can test prototypes. On the lower right picture, you can see the frame that we use in our experiments, consisting of aluminum elements placed in a frame. And then in the upper picture, you can see a schematized image of the flume with the prototype in the center and some sensors. Basically, we were monitoring the waves in front and behind the prototype with wave sensors. We measured the flow velocities and also the forces acting on the elements. And these experiments gave us really useful insights on how to improve future designs. For instance, we learned that when you put the elements far away from each other, they don't really interact. But when you put them with a small lateral spacing perpendicular to the waves, then the flow has to accelerate between the elements, and this increases the dissipation per pole. But then if you put these rows really close from each other, upstream rows shelter downstream rows, which means that this reduces the dissipation of the elements that are placed behind them. So this is basically a less efficient design in terms of saving material costs. So the conclusion was that you can get higher dissipation per pole using the configuration with the dense rows. Of course, this is going to depend on your local conditions in the sense that this configuration gives you higher dissipation per pole, but also higher forces. So it's important to check that the local sediment and the way that the structure is going to be constructed is going to be such that you can have this configuration being stable. What we also tested is the effect of having vertical elements and placing them horizontally. For instance, you saw previously in some of the pictures that some structures have horizontal bamboo poles, or they have the brushwood filling. And what we learned is that when you place the same element horizontally, you have higher dissipation per pole for short waves, but then for long waves, the dissipation of horizontal and vertical arrangements is comparable. So basically, depending on your local conditions, having the elements horizontally may be or may not be an advantage. And finally, so far I've been discussing mostly about how to place the bamboo poles, but as Peter mentioned before, it's very important to also study how far you should place them from the coastline with respect to other structures in order to maximize the habitat creation behind the structures. And another important point is also in relation to this, what happens with subsidence. Because basically, when the bed is sinking, subsidence gives you a higher increase in the water level, and this can be compensated to some point by the accretion produced by the structures. But as Peter mentioned before, if you have an extremely high rate of subsidence, there may simply not be enough sediment in the system to keep up for it. So it's important to investigate until which point, until which level of subsidence, these structures are a feasible solution for restoring the mangrove habitat, not only for this project, but also for the extension at other locations. Well, thanks a lot for your attention. If you want to learn more about the details of this work, you can also find us in our website, biomanco.org, and basically there we're uploading all the reports of the students that have been working with us for the last years, also sharing our scientific publications. So if you want to learn about the technical part, many things are there. And also, we wanted to finish saying, well, a special thank you to all the people that made this project possible, to all the students of UNDIP that have been supporting us in the field during the last years, our Indonesian supervisors who made this project possible, and also, of course, like our institutions, UNDIP, NEOS, TUDEL, for funding agencies, and WO, EcoShape. And yeah, thanks everybody. It was really nice to do this project, and you can always contact us if you have more questions.
Thank you very much, Ms. Alejandra. It was a great presentation, and we will have a discussion after all of the presenters gave their present. Okay. For the next presenter, I will invite Mrs. Sciene. With the title is Building with Nature in the Mud on the Rehabilitation of the Mangrove Forest. Can mangrove outgrow anthropogenic stressors? So please, Mrs. Sciene,
yeah,
nice to see you again.
Good afternoon, everyone, and good morning for my Dutch colleagues. Can you already see my screen?
Yes, yes, we already see your screen, and we can start.
Okay, excellent. So good afternoon, everyone. My name is Sciene van Bijsterveld, and welcome to my talk, Restoring Mangroves in the Muck, Mangrove Resilience to Anthropogenic Stressors. So I am one of the 3 PhDs in the Biomanco project, and my focus has mainly been on the ecological side of things. So Alejandra already really nicely introduced the structures, and Peter already gave a nice overview. And we started out with this PhD with the idea that it would be an asset to the coast to have a buffer between the land and the sea. And so we've been looking into how to restore mangroves and create a mangrove greenbelt along the coast. Now, it's one thing to restore the mangroves in place, but once you have them there, you need to keep them there somehow. And that's interesting because, of course, we want to restore these mangroves along the coastline that's very densely populated. So there are many potential stressors that could affect these mangroves once you have them in place. So I've been looking into a couple of these stressors. Of course, there's the aquaculture itself, that the land conversion that sort of diminished the mangrove cover in the first place. Then there is a lot of plastic waste from all the cities, the villages, all the rivers that enter in the area. And we see whenever we go into the mangrove forest, there's lots and lots of plastic. And that could possibly hamper the mangrove growth as well, because it can cover the pneumatophores of the trees and thereby suffocate them. Then, of course, there's the land subsidence issue that was already discussed in many of the talks today. which could not only influence the habitat for mangroves, because mudflats are also slowly drowning, so that means that there's less place for the seedlings of mangroves to settle, but at the same time the mature trees are also sinking slowly, and which could drown the trees because they end up at a level where they would not normally grow. And then finally there's of course the waves. Now mangroves all around the world have a problem with waves, of course, because there's erosion and they can uproot the mangrove trees, but the wave problem is also increasing because of land subsidence and sea level rise, because the water levels are increasing. So these are 4 factors that I looked into during my PhD. Unfortunately, I don't have time to discuss all of them, but we're going to look mainly into the resilience of mangrove trees towards these stressors, and to look into potential factors that could counteract each of these stressors, because those are interesting to manipulate for restoration and conservation purposes. And I'm going to focus on 2 of these stressors I think are the ones that are most urgent right now. So that's the effect of plastic waste and the effects of land subsidence on mangrove trees. Now, the land subsidence...
Hey, godverdomme, blijf van me eten af.
Oh, nou, ik had... So just a general overview of the land subsidence issue. This is the conventional coastal structures where waves would come in, break on the structures, cause scour. This is the idea if you have a mangrove buffer in front of your coast, waves are attenuated, so the sediment in the water column can sink to the bottom and you get a more stable foreshore. If you have land subsidence, however, the whole foreshore is sinking, there needs to be more sediment to fill up this gap, and your mangroves need to be able to outgrow that sedimentation. So we had 2 questions regarding this resilience question, basically. First, are mangroves resilient to this amount of sedimentation, especially if we would, for instance, hypothesize that the average subsidence rates are about 20 centimeters per year. The mangrove should be able to outgrow also the sedimentation of 20 centimeters per year. And in addition, is there actually enough sediment to maintain this foreshore? So those 2 questions, we went into the field and we did an experiment related to sedimentation. It's a very simple experiment, actually. We did this on saplings and on mangrove trees. We put a surround on each of those and we just added a lot of sediment. So we had a treatment with 20 centimeters of sediment for saplings and young trees, and we had a treatment with 40 centimeters of sediment in one go. And what we saw with the saplings is that in general, they're really resilient to sedimentation, which makes sense because they usually grow in this type of area. But if you would add 40 centimeters of sediment to the saplings, they are starting to get difficulty outgrowing this because, of course, they're relatively small still. So this is a large part of their height that's actually covered in sediment. With the young trees, it's getting even worse. And also that makes sense because these trees already rely on their pneumatophores for oxygen penetration into the sediment and respiration. So they are affected in terms of their nutrient uptake by this. And you can see that the 20 centimeter treatment is already having a little bit of an effect on the survival, which is on the y-axis. Of these mangrove trees, and if you really dump 40 centimeters of sediment on top of their root system, they simply die. They cannot survive that amount of sedimentation. So can mangrove trees outgrow sedimentation? Yes, they can, up to a certain extent. They're actually, I think, surprisingly resilient, but there is a limit to that. So that's something that we should keep in mind. And then the second question, is there enough sediment available? Now, what we did here is we went to different mangrove locations along the coast. So we have Semarang here in the corner, lower corner, and then the Wulan River Delta near the north. And we visited all these different small mangrove stands, and we measured the amount of land subsidence. So what we found was that there is this gradient with land subsidence, with more subsidence towards the city of Semarang, and the less it becomes, the further away you go. Then we looked into erosion that was occurring at each of these locations, and we noted that this was not really the same trend, but there was one location where there was really basically only erosion, and near Semarang as well, but this location was specifically very erosive. And if we then look at the mangrove survival at each of those locations, we can see that this location is definitely having more trouble than the others. And you can still see this combined effect of also the land subsidence. So the locations near Semarang are having more trouble with mangrove survival. And if you add the problem of the sedimentation in there, mangrove trees are really, really struggling. So is there enough sediment available to outgrow this or to overcome this subsidence problem for mangroves? No, it appears not to be the case, actually. So that's something to really keep in mind. And then the second problem that I wanted to discuss, the amounts of plastic. So we visited all these different mangrove locations and we noticed that there was a lot of plastic lying around. So we just started monitoring that and used quadrats placed at different locations in the forest to estimate and quantify the number of plastic items in the plastic cover. And we found that in many places it was almost 50% or more of the mangrove floor that was covered with plastics. And not only that, but it was also buried in the sediment. And therefore, in some locations, if you would have sedimentation and plastic at the same time, it would enter on top, or it would end up on top of pneumatophores, which could suffocate it. And we actually saw this happening in the field. So this is one of the locations where we found a plastic item, and when we removed it, we saw all these very deformed pneumatophores. So the tree is really trying to outgrow the plastic on top of its roots. And actually, a lot of it is already known on how much plastic can be found in mangrove forests. So in that sense, it's not really new. But what we did not know is what actually the effect was on the mangrove trees. And that is something that has not really been looked into before. So we did an experiment, again, relatively simple. We just applied plastic to each of those two different mangrove trees. We had 100% plastic cover where we attached plastic bags to all of the pneumatophores. There was a 50% plastic cover, which is a bit more realistic looking at the plastic cover in the field. And we had a cable tie control because we had to attach the plastic actually with cable ties to the roots, and then an untreated control here in the lower corner. And this is just a picture of how we attached the plastic to the pneumatophores. And what we saw is that all of the trees had a little bit of trouble surviving the experiment. That was because we did this during the wet season, so there was also quite a bit of storm damage. But on top of that, the trees that were also treated with plastic showed clearly lower survival rates and higher mortality. And especially in the 100% treatment, only 40% of our trees survived. And so it's clear that plastic does have an effect on mangroves, although again, they're relatively resilient because these trees were still able to survive the sediment or the treatments for the whole course of the campaign. But eventually mortality does increase. So my conclusions related to these two stressors were regarding to plastic waste. Yes, they are resilient, but trees are also stressed. So that's a problem that definitely needs to be addressed as well, next to just the conventional restoration measures that are taken to restore mangroves. Regarding to the land subsidence, are mangrove tree resilient? Yes, again, they're actually surprisingly resilient, but only if sediment is available, and that is not the case. So again, something to keep in mind. And then the other two factors, I wasn't able to discuss them today, but I was able to publish a paper on it. So if you're interested, for the waves, it's important to have a very wide foreshore, and luckily we have that in some of the places. So we have mud flats, but if there's no mud flat available, a chenier would also really help to protect the mangroves. And in landward direction, the good news is if agriculture ponds are abandoned, they're a really nice habitat for mangroves to grow as long as they're drained. And if you want to look into more of the details, there's this publication that you look into, and it's on our website. Yeah, so I really like to thank my promoter and my supervisors from UNDIP, and the two students that really helped me with these two experiments that I showed today. Tom Heuts, who did the sedimentation experiments, and Sri Ramadhani from Utrecht University, who did the experiments with the plastic in the field. And yeah, thank you very much for your attention.
Okay, thank you, Celine. It was a nice presentation from you. It was very clear. And yeah, we will have more discussion at the discussion plenary. Okay, I welcome you, Silke Tas, with the title Near Dynamics on Eroding Mangrove Coast. Okay.
Hi, Alice. I will share my screen.
Yeah, Celine, please share your screen. Yeah. Okay. Okay, Silke, the time is yours.
Yes, can you see my screen?
Yes, we can see your screen.
Okay, so hello everyone. My name is Silke and I'm the third PhD candidate of the BioManco project, together with Alejandra and Celine, who have just presented before me. Just like Alejandra, I have a background in coastal engineering, and the focus of my research is on the role of cheniers along mangrove coasts. So let me start by explaining what a chenier or chenier is. In this drone picture, you can see a chenier at the bottom of the picture, this one. So it is a sand ridge, so it consists of sand, but in contrast to regular beach ridges, it's found along muddy coasts. So the sand is lying on top of a muddy foreshore. So this is the official definition. So a chenier is a beach ridge resting on silty or clay deposits, which becomes isolated from the shore by a band of tidal mudflats. And now, why are we so interested in these cheniers? Well, previous research by Celine, among others, has shown that the cheniers can provide shelter for mangrove forests. So they form a buffer against waves, and they create behind it a calmer area where mangrove trees can grow. So here you can see the waves, and behind it, it's really sheltered. However, not much is known about the dynamics of these cheniers. This animation shows us Google Earth images over a period of 15 years. You can follow the month and year each picture was taken. And you can actually see how dynamic these cheniers are. They appear, they disappear, and they move simply in a couple of months. Yes, and then this final picture shows us the situation of a chenier in front of the coast of the Mac when we went into the field. So we decided to investigate the chenier dynamics in the field. So we set up field measurements in October until December 2018. And during these 2 months, I monitored this chenier in detail. So the red line indicates the measurement transect, along which we installed several instruments to measure water levels, waves, currents, and bed level changes. And here you can see the frames to which we attached wave loggers and ADVs to measure currents and waves and water levels. And then starting here on top of the chenier, we also installed set sensors and erosion pins, which we use to measure the bed level. And then we also use the DGPS to measure the exact bed profile every couple of days by walking along the transect. So during these 2 months, unfortunately, we only measured really low waves. We actually hoped to have the transition towards a season with higher waves, but this graph shows us the wave height we measured at a wave buoy that we anchored a couple of kilometers offshore of Semarang. So here you can see the wave droid, and I think these waves were representative for the time that we measured, so lower than 0.5 meter. And if already at deep water, so this was at a water depth of 12 meters, but if already at deep water the waves are really low, then you can imagine that close to the coast the waves are even lower. So actually we were disappointed by this because we didn't expect that the waves were high enough to cause sediment transport, so we didn't expect to see any changes to the chenier while we hoped to measure the dynamics of the chenier. But we actually measured huge changes to the chenier. So here you can see a profile of the transect that I measured with the DGPS on 8 November. So on the left of your picture is the sea, and on the right is the mudflat towards land and a mangrove forest. This corresponds more or less to this Google Earth image of the transect. So you can see that the top of the chenier, this is a part that is immersed most of the time, while here is more submerged most of the time. And then this animation shows you how the profile changed. So this was over a period of 1 month, and just like shown in the previous slide, the waves were relatively low. The submerged part of the profile remained more or less stable, but the top of the channel moved landward and also became lower. So that was an interesting and unexpected observation. So back in the Netherlands, we analyzed the field data to figure out exactly what drove this rapid landward migration of the channel. And during the entire measurement period, the wind came from the southeast, so representative of the southeast monsoon wind, except during the afternoons, most of the days when a local sea breeze would develop. And this sea breeze would then generate some higher waves in the afternoon. And these conditions, they were very regular. So the observations that we have, we can assume that they're representative for the conditions during the southeast monsoon season conditions. And we observed that both tide and waves were able to transport sediment and move the channel. So even though the tidal range in the Mak is relatively small, the tide was still able to transport sediment, mainly during the period when the channel was just slightly submerged. And then the tide would flow over the channel towards the land, transporting sediment. While at ebb tide, the flow would actually be around the channel and thus not sediment being transported back to the sea. And while the southeast monsoon wind is offshore directed, so this does not generate high waves because of the land is sheltering, the sea breeze would generate some waves, and these waves, although not really high, they were high enough to stir up sediment and transport it towards the land. So both the tide and the waves, even though relatively small in this season, were still able to transport the sediment. But it's actually the timing between the tide and the waves that is crucial, because in the afternoon, when the highest waves occur due to the sea breeze, this time the water was around mean sea level. So the channel wasn't submerged, and as a result, the waves didn't create a huge sediment transport. However, one day we had higher waves at the same time as a high tide, and then we saw a big change in the bed level. So it's really the timing. When the high waves coincide with the high water levels, that's when big changes happen. But what about the other season, the northwest monsoon season? So we don't have any detailed field data from that period. We also didn't measure during a storm, so we don't know how storms affect the channels. So in the next step, we will use a numerical model in Delft 3D to investigate those circumstances that we weren't able to measure. So we use the measured conditions to validate the numerical model, and then we can use that model to look into different conditions. And if we're able to understand the channel dynamics during both seasons and also during storm conditions, we can use that knowledge to predict how channels will change over a couple of years and what the future is. And because those channels are so important for the stability of the coastline and the fate of the mangrove forest on the coastline, this will help us to predict the future of the coastline itself. Thank you for this opportunity to present my work. I would also like to thank my supervisors, Helmi from UNDIP and Bas van Maren and Alteniers from the Netherlands. If you have any questions, we can discuss them later during the discussion, or you can send me an email via this email address. And I would also like to thank the students and all the staff from UNDIP to help us organize this field campaign. Without you, it wouldn't have been possible, so thanks a lot.
Okay, thank you very much, Silke. Yeah, it was very good, the presentation, and yeah, I think all of you guys are missing Semarang now, I think, and wanted to visit the Mak again, I think. Okay, maybe for the next presentation will be presented by Foko with the title Building with Nature in the Mak on the Socio-Economic Condition. Okay, Foko, the time is yours.
Thank you very much. Can you see my my screen?
Yes, clearly.
Yeah. Thank you very much, Adis, for being able to present here, and also thank you for participating in this session. My name is Fokke van der Goot. I work for EcoShape, which is a Dutch foundation that is responsible for executing the Building with Nature program, which is a knowledge and innovation program to investigate concepts regarding nature-based solutions for water infrastructure. And the Building with Nature Indonesia project is a very important project for us. And I would like to tell more about the socialization part and also the mainstreaming of the concept and how fundamental research conducted by Biomanco contributes to this process. So the project we are executing in the MAC and what Biomanco did is part of a larger program, which we call the Building with Nature Indonesia project. And that focuses on two parts. First, implementation of Building with Nature measures, physical measures in the field in the MAC, focusing restoring mangrove coasts and revitalizing aquaculture in the region. And by implementing these measures, we try to learn from them and we try to upskill and mainstream them so they can be applied elsewhere in Indonesia and also outside Indonesia in Southeast Asia. So the Biomanco research and also the PASMI research conducted by the Wageningen University together with UNDIP, focusing on sustainable aquaculture, they provide like a fundamental knowledge development to support the innovation that we are testing in the MAC. So this fundamental research is super important, but besides this fundamental research, it is crucial that also these applications are accepted by the government and also by the local communities, because in the end they have to continue working with these type of measures. So this picture is very similar to what Sciene presented. The area in the MAC is, there are several zones you can identify based on the level of subsidence and the level of erosion. And for each of the coastal zone, different measures are designed. For the coast towards the Wedung Delta, we try to maintain a position, and the further we get, the closer we get to Semarang, we want to more protect and extend the coast back to its original position, which is very challenging, as we've seen in the previous presentations. I'm not going into detail about the physical measures because we have seen them and they have been explained by the previous presenters. I would like to focus on the acceptance of the measures by the communities and how communities can be involved in realizing this in a full-scale landscape. So in order to do this, to get these communities on board, the so-called community villages were started. The 10 villages along the coast of the MAC were engaged, and farmers owning aquaculture ponds were engaged, trained to revitalize their aquaculture and to train them also in understanding of what the importance is of mangrove conservation and mangrove restoration in their future development of the land. So we distinguish three types of aquaculture ponds in the area. The blue ones are the aquaculture ponds that are positioned in the middle of the landscape, and only revitalizing and revitalization of these ponds can happen. The ponds that are yellow are located along the rivers, and we try to apply mixed mangrove aquaculture here, which is integrating the river dynamics into the ponds, so mangroves can grow back in the ponds, which will result in a more healthy aquaculture system, and also a higher production rate of these aquaculture ponds. Thirdly, we have the green ponds that are located in the original mangrove greenbelt, and through dialogue with the communities, we have agreed that these ponds are, you really cannot apply aquaculture in these regions anymore, because it's better to restore mangroves in that area, so coastal protection is enhanced in these regions. So we distinguish three types of aquaculture ponds, and we've tried to engage the communities to apply sustainable measures to restore and to revitalize their aquaculture. And this is done in various ways. We have set up coastal community schools to train the local villages in how the system works, how sustainable aquaculture works, and we have done that through actual pilot testing and see and show that it works. I think that's one of the key aspects of the Building with Nature application is that when you explain it and when you test it in the field, the same with the permeable structures, the people see that it works and try and getting enthusiastic and also try to get their own community members enthusiastic. So the community increases to apply this measure. Another very important aspect is the community ownership. So initially we started constructing these permeable structures ourselves and starting to revitalize these aquaculture ponds ourselves. But over time, we have conveyed the ownership of these structures and the maintenance of these structures towards the community. So they are better positioned in taking care of the measures themselves rather than relying on external contractors and international organizations. So they are better positioned in understanding how to apply this measure. And also for the long-term perspective of this area, it is very important that they are responsible for applying these measures. But it takes time. So it took about 3 to 4 years to train and to learn and to test various methods. And we're slowly getting to a optimization of how this maintenance and structure building becomes. And this process has also made the national government enthusiastic for this application, and they have replicated this this concept at over 10 locations within within Indonesia, at Java and also other islands. So the fundamental research is crucial for really understanding how these innovations work in practice. It is also important that fundamental research in this case is part of a larger integrated approach that we can convey these lessons from the scientific research towards the community and towards local educational programs. So for the long run, they can be applied by the local communities. So it's a very complex interaction between knowledge partners, local communities, local universities like UNDIP, NGOs, like Blue Forest, specialized in aquaculture, revitalization, the ministry at national level, provincial level and local level, and also the engineering firms being able to design practical applications that can be applied elsewhere. So it's a very complex interaction between all these stakeholders, but it is vital, and this was also explained by Herman in his conclusions, that this interdisciplinary approach is crucial for upscaling these innovations like we've done in the MAC. So mainstreaming building with nature needs collaboration between sectors, and it also needs testing and implementing these concepts in practice. And it only works if you want to upscale these concepts, that these practices are supported by fundamental knowledge development, such as Biomanco and also PASMI. We need to translate these fundamental research into practical guidelines, which we do as a program, and they will be publicly available, and they need to be developed in a collaborative network. And only this can result in upscaling and mainstreaming of nature-based solutions for these vulnerable areas. And in that sense, the Indonesia project is part of a wider scheme of nature-based solutions that you see globally. There's a big interest in it, and the project in the MAC is a lighthouse example of how this is done together with the communities and the local stakeholders. Thank you very much.
Thank you very much, Foko, for the nice presentation. But there is a little bit problem with the PowerPoint, so I think it's a little bit overlay with the other, maybe the other application in your laptop. Yeah, there is a little bit. There's a little bit.
See my presentation?
No, we can see the presentation, but it's overlaid with the other application. Yeah.
Okay.
Yeah, but it's okay. It's quite clear for us. But if after this session, are the presentation available for us to read again?
Definitely.
If it's okay, you can send it to us, and we will distribute it to all the participants who join here, so they can read it again from your presentation.
Sure.
Thank you very much, Foko. So we come to the first discussion for the questions. For the first questions is from Miss Intan to Pak Wisnu. So as we can see from the result, density and income become prominent factors in the vulnerability assessment in the case of North Pekalongan subdistricts. Could reducing density be the solution to reduce vulnerability in those kelurahan? Pak Wisnu, can you answer these questions?
Yes. Yes. Thank you, Intan, for the question. Yeah, I'm very glad to answer the questions. Yeah. So according to the densely populated marginal area, I think from my opinion, in the long term, yeah, so the settlement regenerations projects, yeah, through land readjustment might be considered, yeah, because I think it would be better to resolve the problem of marginalizations in a comprehensive way. Yeah, for me myself, the problem is not about the density, yeah, itself, but rather the landed houses pattern, yeah, or the low-rise housing. Yeah, and if we look at the carrying capacity, or if we look at the yeah, let's say the land subsidence, yeah, the coastal area need for more open spaces, yeah, not only for the human well-being, yeah, like the the development of the public spaces, green spaces, yeah, for the recreation facilities, but also for the conservation, yeah, area to the land subsidence, like we can provide with the mangrove forest or the other kind of the conservation area. Yeah. So in this context, the vertical housing, development of new settlement facilities should be the appropriate strategy. Yeah. So I think not only about the new development of pattern of housing or pattern of the settlements, yeah, but it should be completed or facilitated with the new economic opportunity. Yeah. So I think we can resolve the settlement pattern, yeah, altogether with the emergence of new opportunities for new investment, yeah, for job creations, yeah. So I think not only the problems of settlements can be resolved, yeah, but also we offer the new living environment or the new opportunity for the people, yeah, to make them living better, or to increase the quality of life of the community who lives there. Yeah, so I think again, with respect to the settlement density, I think it is okay, yeah, to exist to them, yeah, to still exist or still reside in this area, but we have to think about the urban regenerations. Yeah. That is my perspective, and that's all I can share to Intan. Thank you, Pak Aris.
Okay, thank you, Pak Wisnu, for the great answers. So for the next question, are there any participants who wanted to ask directly? Please raise hand. Are there any participants who wanted to ask? Or can I ask Bas Van Maren to ask the question, because the first question has been answered by Foko, and the second questions from Bas, I think it's from it's to Silke. So question related to the work of Silke. For a wider audience, is there anecdotal information on the presence of seniors before land subsidence? Did the cheers already exist for a longer time? If yes, where is the sand now? Maybe Silke can make some confirmation of Bas' questions?
I was actually wondering if maybe there's some local knowledge about this, because yeah, it's something that's more difficult to estimate from the Netherlands. So yeah. I don't know if there's anyone else in the audience who has knowledge about this.
Okay, Silke. Pak Priyo, maybe. Pak Priyo, do you have any knowledge about this, Pak Priyo? Because Pak Priyo is the civil engineering from the civil engineering department. Do you hear my voice, Pak Priyo? Pak Priyo, I think Pak Priyo is not. Okay, maybe for the next, maybe we can skip for the next one. Maybe because basically related to the engineer, I also don't have any capacity to answer this still because I'm still learning also. So maybe we can have another question. Bas, do you wanted to ask directly to one of the participants? Because you already unmuted.
Yes, sure.
Okay.
So I want to raise my hand, but I haven't found out the button yet to raise my hand. So, but my question is related to measures to reduce subsidence in the area, because as Peter said in his introduction, with the present rates of subsidence, it is basically impossible to create coastal progradation, and that may have a negative feeling for the whole project. So it's something that we cannot solve. But on the other hand, we can also look at it positively. If subsidence rates are reduced by measures being taken that leads to land subsidence, and in the future the land subsidence rates decrease, then at a certain moment you may reach a critical sea level subsidence rate where actually all the measures that we are now experimenting with can be successful in regaining the historic loss. But a boundary condition is then that measures are indeed being taken to reduce the subsidence rates. And my question is, are such measures being taken?
Who do you want to ask, Bas?
Well, I am not sure who is capable of answering that question.
Okay.
Is there anybody in the group able to answer that question?
Okay, maybe Peter or maybe Han maybe can answer this question, or maybe Adreniers.
I can add some information to it,
yeah,
if
okay.
I may.
Please.
Bas, it's of course, a very good question, and the subsidence issue in the MAC was, I think, addressed only quite recently, actually. So the dialogue about this topic has started maybe 1-2 years ago only to address the issue. So let alone talking about the solving it. I think we are not, they are not that far yet. So I think the Indonesian government are working on an action plan to address subsidence at a national level. But I think we are far from taking measures to stop groundwater extraction yet, unfortunately.
Okay. Thank you, Foko, for your answers. Yeah. Maybe anybody else wanted to add the answers? Maybe Peter or Han?
I can only see the consequences, but I don't know exactly what the policy is and what. I just wanted to stress it is if you're thinking about the future of this coastal area in the MAC, if there is any future, it will only be through controlling the subsidence, because with the present rate of subsidence, it's lost, and you can better remove the houses now, then let the people drown, because there is no future unless you do something about the subsidence. And so I think this is really really urgent.
Okay, thank you, Peter. So Bas, I hope you are satisfied with all the answers from the source. Yeah.
Well, yeah, of course, satisfied in the sense that my answer is my question is answered. I'm not so happy with the answer, but that's a totally different matter.
Yeah. Maybe, yeah. Okay.
May I add one thing? So, do you hear me?
Yes, Han, we hear you.
Some time ago, in the training programs, we had a very nice presentation on the geological development of this whole entire Sunda basin, of which Java is part of. And so what we're talking about now is the subsidence rates of 10 centimeters per year and the coastal retreat, etc. But basically, we have to realize basically what's happening, that is we're setting back the entire coastal development of Java by 5,000 years. If you look at the conditions 5,000 years ago, then the coast started to develop slowly because of the erosion of the mountains, and the sediment was transported towards the coast. So the entire northern plain of Java is alluvial. It's sediment which came from the mountains. Erosion continues also because of the method that the way the land is now being cultivated. But I think it is, if you want to discuss this also with authorities, with management, that these enormous time scales that we're talking about, have thousands of years, are really important to put on your mind.
Okay, thank you. Thank you.
Yeah, it may also be a good idea to start making projections that with the present subsidence rates, what will be the land area that will be lost. As Peter indicated, it's better to remove the people now instead of letting them drown. But if you project where we think the coastline will end with the present subsidence rate for an X amount of years, and you create a map of the area of Java that will be lost, then you have a very strong argument in in speeding up legislation to reduce water extraction.
Okay, thank you. Thank you, Bas. So maybe if I can add related to the condition of the subsidence in Central Java, or generally in Semarang. And we also have some project with the USA universities that now are trying to predict what is the most, what do you call it, the most cost from this land subsidence, because from the geological point of view, it's still debatable between because of the ground extraction, or is it naturally because of the Java has a very soft layer, so it's basically naturally the land of most of the central of the northern Java is subsiding naturally, but because of the everyone said because of the groundwater extraction, but it's not proven yet. It's not been researched by doing very well. So so we have some collaboration also with the Boston University, and then from the France to to try to figure it out, which one is the most cost of this land subsidence. So yeah, we are still working on it to know the land subsidence, because Indonesia, it costs a lot of funding also to do that research, and I know it's quite challenging also for us, and hopefully in the next 3 or 4 years we can try now to know what really happened in the northern part of Java.
Iris,
I think, yeah.
May I add to that? You are, of course, completely right.
Yeah.
That there is a number of processes which cause the subsidence, but at the same time, natural consolidation, geological processes, we cannot control as human beings, as societies. The only thing we can control is the subtraction of groundwater. And whether it contributes a lot or 50% or 30%, that's important to further investigate. But it is certain that if you stop groundwater subtraction, that you will reduce subsidence. I mean, there is the famous example of Tokyo, which was sinking rapidly. It is about the same conditions as in northern Java, so it's alluvial, there's a lot of mud. And when they stopped withdrawing groundwater, the subsidence rate decreased rapidly, and it's now small.
Yeah. Okay. Thank you. Thank you.
The
Han,
other thing which I would like to add, and that is maybe something for UNDIP. So we talk about subsidence, but we also talk about coastal erosion. And for me, it is not obvious how to define, because if you look at Google Earth images, we see enormous amount of water coming in Sayun, but it is partly because of drowning and partly it is erosion. But what is it? Because there is still, for instance, a road which protects the hinterland. So in analyzing satellite images, as the first speaker did, Mr. Hadi, I think it's good that Indonesian comes with a generally accepted standard on how you define and where you define the coastline and how you define coastal erosion. Because otherwise, people are talking about completely different issues. You talk about a lot of water, 5 centimeters from the satellite image, you don't see whether there is a 5 centimeter water depth or it is 1 meter. You don't see that. And of course, it's also affected by the level of the tide. And so you have higher water, then parts may be inundated, but not really eroded, because they are just subsiding. So I would suggest that maybe UNDIP can take the lead there to come up with a good definition, a standard on how you define the coastline and how you define coastal erosion.
Okay, thank you, Han, for your input. Yeah, we will do more research about this, and I think Pak Firman Hadi also already did some good research for his presentation also. So Pak Firman, do you have any comment with this about this? Do you have any comment?
Okay, thank you very much.
Yeah.
Maybe I will just follow up from your comment related with the your current research with the USA University. That there are things that we are not sure about which cause the land subsidence. Is it naturally occurs or because of the groundwater extraction? Maybe from my background, we can try to do the INSAR processing with the previous SAR images. For example, NVSAT or ASAT. So before the development, for example, before 1990s, then compare the rate of land subsidence. If it's significantly different, maybe we can assume that it is because of the groundwater extraction. Because if it's naturally occurs, then my assumption is the rate of land subsidence will be stable for each period. Maybe that's just my idea. Maybe Department of Geodesy Engineering can try to address that issue.
Okay,
It's
thank
just
you.
one comment.
Thank you,
Okay,
Mr. Firman, for your addition. I think we can continue with Peter. I think you raise your hand, Peter.
Yes, I do not really understand very well where all the doubts come from. This coast has been expanding for centuries, and now it is withdrawing, and observations show that it is sinking at about, in places, more than 10 centimeters per year, and that has never been observed before. And it is not due to compaction because of loading with heavy buildings, because these are just small villages and there is no loading at all. So what else than groundwater extraction could be the cause? I don't see what makes you hesitate about this.
Okay, thank you, Peter, for your comment. Yeah. Okay. Maybe we can get to the next question. I think we have the last question from Pak Priyo. So Pak Priyo is asking to where did you measure your wave? I think it's for Alejandra. Transmission behind of the hybrid construction. And what do you think the biggest contribution of wave transmission, wave overtopping, or wave pass-through between the bamboo or wave diffraction? Alejandra, are you still here?
Yeah, I'm here. So you asked what is the strongest contribution, and you said overtopping,
Yeah.
wave transmission.
Is it wave overtopping or wave pass-through or wave diffraction?
Diffraction, you said.
Yeah, yeah, diffraction.
And the contribution to what exactly?
Contribution of wave transmission.
To
what do you think the biggest contribution of the wave transmission?
Well, I mean, wave transmission in this case for the structures is going to depend on the reflection that you have in front of the structures. So there's going to be part of the energy that is reflected.
Yeah.
But another part of the energy is going to dissipate due to friction in between the elements. And then you have a transmitted wave height. In this case, I think the structures are all designed to be emergent for most of the time. So in that case, I didn't consider overtopping in my research.
Yeah.
And diffraction is for elements that have a bigger size compared to the waves. So in this case, diffraction should be, in principle, a way smaller process. So it would be mostly the reflection and the dissipation due to friction, basically defining the wave transmission.
Okay, thank you. Thank you. Yeah. Okay, are there any questions?
Aris?
Comments, yeah?
I have only one comment.
Yeah.
Actually, I would like to ask how our Dutch colleague create the graphic. So I'm really impressed with the graphs. That's my my not question. It's my impression. Do you understand? So huge appreciation for our Dutch colleague for creating the graph. So I learned a lot on how to present by putting the graph, nice graph. So it's make us understand the process of the topic. So
I understand okay. what you mean, Pak Firman. Yeah, with the simple picture, you can explain everything.
I'm really
right?
impressed.
Yeah. Yeah. Okay, a very big appreciation for all of the participants, especially from the PhD students. They can preserve us with a good presentation and a very clear presentation. Yeah. I think it's a good job for all of you guys. I've known them very well, and they are very tough girls, and yeah, they spend most of the time in Siam City. Yeah. Okay, maybe are there any adding comment from Peter, or maybe from Han, or maybe from the Dutch colleagues? Are there anything you wanted to add, or anything you want to comment for this session? Maybe Peter or Han?
Yeah, maybe one short issue. It is very unfortunate that we cannot be present in person. Personally, but I think the whole team was looking very much forward to see our Indonesian friends again in Semarang. But yes, times are difficult, so it is not possible. We have appreciated extremely very much all the collaboration, the friendship, the hospitality, and not only from UNDIP, but also from the local people there. As you know, we have a continuation of this project. There is a next project coming. Ibu Sri is heavily involved, but I also hope that our older friends, like you, Aris, and Pahelmi, will be involved. If things go well from the Corona point of view, then we plan to visit somewhere in spring next year, 2021. I hope it's safe to travel. I just don't know. But let us assure you that we are extremely happy with the collaboration, that we are very, very disappointed we cannot be there in person. But I think this was a reasonable solution to show our progress and also to express our gratitude. So Aris, everybody already mentioned her, but let me repeat. Thank you very much for giving us this opportunity, and I hope that we can meet in person very soon again.
Hoping to
stay
see
safe
also,
and
yeah.
healthy, everybody.
Yeah,
Take
thank
care.
you very much, Han, for your nice closing speech. I think, yeah. Okay, maybe before we wrap up our session, so we also have what do you call it? We pick the best presenter now. So one of you, one of the participant, will be one of the best presenter, and I will announce it after we have some photo session. I think we need to have some photo session for our documentation for this event. So I can report it directly to you, Han, that this event is do with many participants. We have almost 30 participants in our session, and it's the biggest class in other class that we have in this event. Okay, do you mind for all of the participants can show open your camera, and we can have maybe just one or two screenshot because it's only 30. Yeah, two screen. Yeah, I think we can have a photo session. Please, everyone can. Yeah, I think Lesi or Tria or Fitriana can open your camera. Yeah, and Pak Max. Hello, Pak Max. Nice to see you here. This is Pak Max, whose paper is being discussed by Mr. Firman Hadi, I think, yeah. Okay, please give your best smile for this session. Is it enough, Burika? Can you raise your thumbs up? So with the Indonesia style. Okay, thank you very much. Thank you very much for all of your time, and I will announce who is having this best presenter. Okay, maybe the operator will share it. Yeah, so the best goes to Alejandra Quijot Manqueno. Congratulations, Alejandra.
Thanks a lot.
Do you want to have a photo session with? Yeah, maybe we
Okay.
can take a picture with this. Yeah.
Okay, what should I do?
Just give us the biggest smile from you. Okay. Okay, thank you very much, Alejandra.
Thank you so much.
Yeah, maybe, hopefully we can see next year. Maybe I can go to the Netherlands next year to meet all of you guys with Pak Firman. I will brought Pak Firman also, Netherlands. Okay, Pak Firman. Okay. Thank you very much for this session. I'm very happy to see all of you from the Netherlands and all of our colleagues from Indonesia. I hope all of you are in a good health, and I hope this pandemic will be getting over, and we can do more collaboration and do more research related to the issues in the coastal areas. I think we have one last session is the closing from our dean. So maybe we can have a look the closing for our dean. Thank you.
Bismillahirrahmanirrahim. My respect to distinguished speakers, presenters, sponsors, supporters, delegates, professionals, and all participants. Praise to be to Allah Subhanahu wa Ta'ala for granting us the opportunity to organize ICTCRED 2020. I am very pleased to know that we have finished this 2 days event splendidly. Moreover, I got report from the committee that all participants have given your best to deliver your abstract, poster, and presentation. It is a big pleasure for us to facilitate you in disseminating your wonderful work. I also would like to congratulate the winners of Best Poster and Best Presenter. However, 2 participants who are not win the competition will not be discouraged because I believe you also have did your best. Let's continue doing our wonderful works to help our country to overcome the problem in fisheries and marine ecosystem. As the Dean of Faculty of Fisheries and Marine Science, I would like to thank all committee who worked very hard for these past 10 months to prepare the 6th ICTCRED. Without all of you, this international conference would not have been possible. At the end of my speech, I would like to invite all of you to join our next ICTCRED. And let's pray the pandemic will over very soon, hence we can meet and discuss directly. I do hope you can get a fruitful share with other scientists and build potential collaboration for the future. Wassalamualaikum warahmatullahi wabarakatuh. Thank you for.
Okay, that was our closing from our dean. So before I end this session, there are a few information for all the participants who join the publication. So we will need maximum for the full paper is on November 15. And if there are any questions from the participant, you can email us, or you can, if you have my contact, you can contact me directly related to the full paper from your research paper. Maybe that's all from me. And I'm really sorry about the disturbance or any technical issues that is happening at this session, because technology sometimes make us very easy and sometimes make us very difficult because of there's some technical issues. Okay, I would like to thank to Han to support our conference, and I also wanted to say thank you for the TU Delft, and then to the NWO, and then also from the NIOS. I recently see Church Boma also on this session. I hope all of you are going to be in a very good health for everyone. And to all my colleagues in Asia, thank you once again to be patient in this session, and I hope you have more knowledge and more perspective or point of view. For us, it's going to be a very big homework for us to solve all of the problems that are happening in our country. Thank you very much, and I will see you soon in another session or in another event. Thank you very much. Good morning, everyone, or good afternoon, everyone.
Good afternoon.
Yeah,
Yes.
bye-bye, everyone.
Bye.
Bye-bye, Peter and Foko. Thank you very much. Thank you very much. Ibu Sri,
Halo,
thank you very much. Ibu Sri, halo Ibu Sri. Thank you very much.
Terima kasih sudah diundang.
Ya, terima kasih.
Halo Pak Han.
Dang Joel.
Halo Peter.
I still remember a little bit of Netherlands. Dang Joel.
Terima kasih.
Yeah. Oh, Han, you still remember Indonesia?
Yes. I'm waiting for your coming here.
Yeah, we are waiting for you to come here. We are very waiting to come you to eat this Indonesia spicy food.
I'm ready.
Selamat sore.
Yeah.
Selamat sore.
Selamat sore.
Selamat.
Bye everyone.
Bye
Bye everyone.
Bye bye.
Bye bye.
Alejandra, Celine, and Elina. Terima kasih Elina.
Oke.
Pak Helvi, makasih Pak Helvi.
Ya.
Sampai ketemu lagi di pelayaran berikutnya, Pak.
Thank you, Pak.
Pelayaran, saya diajak aja, Pak. Pelayaran, Pak.
Ya deh. Udah ya.
Ya, sampai ketemu, Pak. Thank you.